We all have heard of Java. Many youth are now pursuing it as a full-time career option, with Java-based developers being in such a huge demand in the recent times. We all know that many participants in our audience would have wondered if they can learn Java and full stack development at whatever stage of career path they are on, and whether it's a good idea to start now. If the answer is yes, our next topic deems to cover this exactly. Let us now understand a roadmap of full stack development career from an expert in this area. I would now like to welcome Mr. Ramesh Ekambaram as our first esteemed speaker. He is the Assistant Vice President of IT Services at a leading MNC bank. He has completed his bachelor's in electrical and instrumentation engineering. He is a senior IT professional in technology, application support, and financial service industry with more than 30 years of experience. His professional traits include being a coach, firefighter, mentor, motivator, and public speaker. Mr. Ekambaram believes that an insight to see and perceive an opportunity in every situation and to convert it into a positive, beneficial outcome brings true success. Please join me in welcoming Mr. Ekambaram. It is an absolute pleasure to have you with us here today. You can now start with the session.
Thank you, Tamisha. Good morning, everyone. Am I audible?
Yes, Mr. Ekambaram, you're audible.
Thank you. Thank you. First of all, I would like to welcome all of the participants and would want to, say that I'm very honored and privileged to be given this this wonderful, opportunity to, talk to everyone today on the 74th Republic Day. Um, so, thanks to all of the EduBridge team and all of the participants once again for giving me this opportunity. Just wanted to touch, before starting off, I just wanted to touch on, this is the 75th Republic Day, right? So this is because the Constitution of India, was formed today in the year 1950, and that's why it's the 74th, and that's when India became a republic separate from the British Raj, right? So because it's the 74th Republic Day, I just wanted to touch on that. Okay. The other one point that I was, keenly listening to your CEO, Girish Singhania, it's the youth right now have a wonderful opportunity because a lot of things have changed. Like you mentioned, even 5 years, 10 years from now, right? So the whole thing is like, the digitalization has completely changed everything, right? And the social media, the access to social media and digitalization. So I think the youth, what I feel from my heart, what they need to capitalize, right? Tap into opportunity is just, we need to understand what we really want, right? What we want to build as a career. So it's important. I'm just trying to echo what Girish mentioned earlier, is that don't see it as a job, see it as a career. It's a long-term, commitment, because you're going to be in this field for, I don't know, 35 years, 40 years. So might as well, make it, interesting, make it, every day you should be charged, right? So that's how you should see this. So it's important to actually think, plan, and really see. You should have an insight as to what I'm really interested in. What is my passion? What is what are my strengths? What are my weakness? And then you need to actually embark on your journey. And that's how you need to take it. All right. So today's topic is just give me a minute, is full stack development roadmap, right? I completely I think that some of you all probably have some experience in programming and probably, employed somewhere. But a lot of you all want to understand what is this, full stack developer journey. How does it start, and what are the things, what are the essential things that you need to, learn, um, uh, practice, develop, evolve? Because now the current age is that every 6 months, right, the technologies are evolving, right? So it is very important that you understand the fundamental concepts, the key core concepts, the building blocks and the structures of what is really essential to build a very strong full stack development path, right? So let me quickly share my screen. Give me a minute. Is everyone able to see my screen? Yeah. All right.
Yes, yes.
So I've just put everything into a concise, short PowerPoint deck where I want to present this to everyone. So how I just want to understand what's the percentage of all of the participants present here have experience in either front end, languages, technologies like Java, or any other language like Python, or like even the front end, for example, HTML, CSS, JavaScript. If you can just, I know it's hard because we have a lot of participants here. So if you can just, give a thumbs up. Oh, okay. Brilliant. Wonderful. Wonderful. Whoops. I see a lot of thumbs up. Okay. All right. So the full stack development roadmap starts like this, right? The first and foremost thing that you need to understand is the front end, right? The front end core part forms the user interface and the user experience, right? The content, structure, design, style, and the whole the way which the website is actually appears to anybody who tries to access. So that's the front end part, right? Then you have the back end. Of course, the back end is a little more complex because the back end essentially consists of the whole data processing, validation, and storing of the data, which is like the database into a database and a server, right? So you need to understand the backend and the database part. Then the third one is the internet fundamentals. How you need to work with the internet. What are ports? What is DNS? Right? What is HTTP? What is HTTP? How is HTTP protocol used? Right? All these things, form the internet aspects, right? The working aspects you need when you're writing a program, right? So you need to know that. And then it is very beneficial if you have an operating system like Linux, right? Because most of the servers, probably I think about a large percentage of servers are hosted on Linux, right? So and most of the interfaces are CLI, is command line interface. So you need to, it's advantages if you know Linux. And of course, everything from now is being ported into, it's moving into cloud. So also if you could, if you have a good knowledge of cloud, understanding of how cloud technologies, infrastructure, their whole implementation, what are the services, who are the big players. So if you understand that, that will really help you in your journey. Okay. With the next, I'll just put it like this, so it's easy. Okay. So I just put it in because even the front end part is like so huge, right? It's so vast, right? But I just, kind of put everything in a small screen, the complete suite. We have the languages, the frameworks, the bundlers and transpilers, the HTTP. So languages, the three core languages is HTML, CSS, JavaScript, right? Yes. So what do you understand from, first I want to talk briefly about these languages. What do you understand by these languages? What is hypertext markup language? So what does that say or signify? Essentially, it it you know it encompasses the basic structure and content of a web page, right? The HTML, right? And of course, you use it with Emmet plugin tool, which comes as a default with VS Code, right? Then you have CSS. What does CSS stand for? Cascade Style Sheet. So the HTML has the content and the structure, whereas the CSS gives us the styling and design of a website, right? And the third one is JavaScript. What does JavaScript give us? The HTML and CSS are basically static. It's very static, static pages of a website. But the dynamic aspect, which is the functionality and the interactiveness, is provided by your JavaScript, right? So these are the three core things, right? I just want to touch upon one thing. Maybe I should have just touched this upon earlier, but I want to better late than never. Why would anyone think of being, anyone want to be a full stack developer or a front end developer or a back end developer? Is it, I mean, you can, answer it in the chat. Or do you think it's because, is it because everything, because we're living in a digital age where technology is very important? Or do you think the salary or the remuneration, the package is very high? It's worth having it's if given a chance, I want to get a job where I can get about like 20 lakh package or 30 lakh package or a very high package, right? Yeah, that's one of the motivation. But what is the essence, which, like, one of the very, very important thing that a full stack developer has? I'll tell you today. It's your freedom. Freedom in the sense you understand the technologies from a front end, from a back end, from the database server aspect, so that you have the freedom to design, deploy, implement, and put something what your dream come true. So that is the biggest essence. So, and the full stack development journey is not an easy one, right? It takes anywhere between 10 to 12 months or almost a year, right, to become proficient, to become confident, to basically say that, yes, now I'm confident to develop an application, right? Develop a website, put it on the back end, right? And so that kind of confidence, that kind of expertise, it takes almost 10 months to 1 year. So I understand that if you want to become a full stack developer, one is you need to definitely be interested. You need to have an inclination towards programming, coding, understanding the technologies, and more than all that, the hard work and the commitment you need to be involved and committed, because you're going to invest almost 10 months to 1 year time to become a full stack developer, right? Why I'm stressing this is very important. When you start your journey of making your career, it is very important that you take time to decide what you want to become, right? See, I understand this is, technology, remuneration, all this is there. But the essential thing is, why I'm stressing this is, you have to understand if coding is for you. If you see, some people would say, like, I want to just be, a UI UX designer. So he would fall more into the front end development. But somebody wants to be in the back end, right? They want to, uh, write a software, which handles data, right? So he would fit into that role. So it's essential that you have a very clear picture as with regards to your interest, with regards to your what you really want to become, and decide on that. And of course, it's a long, arduous journey, but yes, it is definitely it is a well-paying, career, and it's got a very, very bright future. So uh, with that, I would want to get on to the next slide, which is basically, I put a small, in one slide, as to how long all these languages and the framework would take, right? So for a beginner, right, there is self-learning, and there's also the guided curriculum. I'm talking about self-learning, right? You pick up your resources. I mean, there's lots on the internet. You'd have YouTube videos, you have a lot of things. But when you go the self-learning journey, you need to understand that you need to have your key core concepts, that is HTML, CSS, JavaScript. HTML with using Emmet plugin will probably take about 1.5 weeks, right? Max, you can learn, right? And CSS, cascade style sheets, that is with the Bootstrap or the Tailwind framework, whichever is comfortable with you. For you, you can take about 1 month. 1 month. See, all of these languages or framework, you cannot. It's not one thing I want to let everyone know. It's not like, it's not like you've read a book. Yeah, I've read all the pages of the book. It's not like that. And you can never ever master 100% of anything, right? You know the concepts, you understand the concepts, key core concepts, and then only when you start applying it in projects, when you start working on them, you will understand how. See, when you learn a language, you zoom in, right? But when you zoom out and see how that language is just a small portion of an entire application, right? Which is used, like, for example, Netflix or Amazon, or how they've used this, what is the backend, what are the databases, what are the servers, what are the technology. So if you understand this from a very larger perspective, it is very complex, right? So what I would say is, learn your HTML, learn your CSS, and of course, JavaScript with DOM manipulation fundamentals. I'll get to that real soon. It'll take about 2 months, right? So probably 3.5 months, and then you need a month for getting familiarized. I won't say a month, but month is sufficient to understand the framework, how you need to use the framework with that, right, with a complete structure. So I would say 4.5 to 5 months for being a front end, to be confident, say yes, I am ready now. Okay. And it is not just learning the fundamentals, but you need to start working on the core concepts, work on a small project, design a small website, right? You can actually clone a website, right? You can practice by cloning, right? Like you have Paytm, you have Shopify, then you can have a small, web page for registration, for landing, or you can have your own personal portfolio website or your college website. You can just make whatever you want, right? This is just for your practice, right? One thing I just wanted to mention is JavaScript, because see, we've all learned different languages from college, right? A lot of people have learned C++, right? And okay, some have learned Python, some out of their own interests, or having an opportunity, have probably learned Ruby. So the behavior and consistency of all these languages is definitely different. So when we talk about JavaScript, it also comes with some of the baggages or some of the languages that you've learned, and you tend to think that, okay, I have programmed this language, so will this be will it have the same behavior and the interactive functionality? No, it'll be different. So but the most popular one is the JavaScript is very, very essential, very popular. So you need to give yourself a lot of time to understand the fundamentals, especially with respect to DOM manipulation. What is DOM? It's a document object model, right? It's basically an application API or a programming interface for HTML and XML documents, right? So it defines the logical structure of the documents and the way a document is accessed and manipulated, right? How the whole data is handled, right? So DOM basically contains a bunch of nodes where each node represents a HTML element. So I'm just giving you a very, very big overview, right? So it takes about 4 to 5 months, right? 4 to 5 months comfortably to learn, to work on all these front-end development technology, that is the language, the framework, and everything. And before I move on to the next one, I would want to play a small video. Just give me a minute. Please watch this. This is like a very kind of a macroscopic view of what the front-end development, what are the technologies. So it's very interesting. It's a short video, but watch it. It's very useful. So, okay, let's watch this. Thanks.
The front end and the back end. The front end is all the visual stuff you see on the web page, the images, the text, the buttons, and the back end is what saves and manages your data, for example, your Amazon order history. In this video, I'm going to explain all the technologies that are used in the front end of a web application, and in another video, we'll explore the back end. Let's get started. We're going to start with a blank web page, and the first technology we're going to look at is HTML. HTML stands for Hypertext Markup Language and is used to add content to our web page. For example, I can write this bit of HTML to add a button. I can also add other types of content like images and text. And if I write more HTML, it will add more content to my page. But you'll notice that our page doesn't look very good. That's where CSS comes in. CSS stands for Cascading Style Sheets. And based on the name, it's used to style our web page. So it's used to make our web page look good by letting us adjust colors, sizes, spacing, things like that. Let's add some CSS to our page. So now that looks much better, but we're not done here. Let's say that I want to filter these products and only show one brand of shoes. So I click this checkbox. But you'll notice that nothing happens. And this is where JavaScript comes in. HTML and CSS only display things on our web page, but JavaScript is what makes our web page interactive. So for example, when we click something and type something, a bit of JavaScript code will update the page based on what we did. The most important feature of JavaScript is something called the Document Object Model, or the DOM. The DOM allows JavaScript to change the web page. For example, this bit of JavaScript code uses the DOM to change the text in the button. And this is how JavaScript makes pages interactive. However, using the DOM directly like this is really repetitive and hard to manage. And that's why we use a JavaScript framework. JavaScript frameworks give us a much nicer way to create our web page, and they take care of updating the page for us, so we never use the DOM directly anymore. The most popular ones are React.js, Angular, and Vue.js. Now let's take a step back and look at JavaScript again. JavaScript as a language is missing a lot of features that other programming languages have. One of these features is being able to split up our code into different files and to organize our code. To solve this, we had to use something called a bundler. The most popular one you've probably heard of is called Webpack. Webpack lets us split up our JavaScript code into many different files, and once we're ready to put it on our website, Webpack will combine all of these files or bundle all of these files into one JavaScript file that we can put on our website. Another tool that we use is called a transpiler. The most popular one you've probably heard of is called TypeScript. A transpiler adds extra features onto JavaScript. It lets us write an enhanced version of JavaScript, and then once we're done, it will transform the enhanced JavaScript back into normal JavaScript, because browsers like Google Chrome can only understand normal JavaScript. So those are the major technologies in the JavaScript world. Now we're going to move over to CSS. CSS as a language has the same problems as JavaScript. We can't organize our code into different files, and CSS is missing a lot of useful features. So we also use a bundler and a transpiler for CSS. There's a special name for this called a CSS preprocessor. It's basically the combination of a bundler and a transpiler. The most popular CSS preprocessor you've probably heard of is called Sass. Sass lets us organize our CSS into different files, and it lets us write enhanced CSS. And then it will bundle all of those files together into one file, and it will transform the enhanced CSS back into normal CSS. So you can think of it sort of like a bundler and a transpiler combined. Now, once we had CSS preprocessors, developers started to create CSS frameworks, the most popular one being Bootstrap. CSS frameworks are basically a whole bunch of CSS code that someone else wrote, and it helps us solve common problems. So using a framework like Bootstrap saves us a lot of time. The last thing we're going to look at is how does the front end communicate with the back end. For example, let's say I'm on Amazon and I want to make an order. How does this order get sent from my computer to Amazon? JavaScript has a feature for this too, called XML HTTP request. It lets us send a message. In this case, we're going to send our Amazon order to a URL like amazon.com/createorder. On the other side, Amazon's backend is listening for these messages sent to this URL, and that's how they get our order. We're going to talk more about this process in our backend video that you can find in the description. Over the years, we've improved on XML HTTP request, and these days we use tools like Axios or Fetch to send messages to the backend. Alright, so these are all the technologies we need to build the front end. You'll notice that it's really just HTML, CSS, and JavaScript. The other technologies make CSS and JavaScript easier to work with. Let me know in the comments how many of these technologies you already knew, and if anything.
Okay, so okay, 1 second. I think, is there a disturbance? I mean, I'm having probably, it's my internet, so just give me a minute. Let me. Okay. So how do you find the front end part, the video? Was it really with the, I mean, the concepts clearly explained, the brief? It's a very, very brief overview, but I think we've touched all of the the languages, the frameworks, and what's a transpiler, what's a thing. So it's very essential that you understand all this, because this is this is kind of the complete fundamental structure for the front end development path, right? Okay, I see a wonderful video. Oh, wow. Yeah, I will definitely send across the YouTube video and the presentation to the EduBridge team, and I think probably they will share it with you, right? So, do you want me to move over to the backend, or is there any you want to have a small break, ask some questions, or I'll leave it to the team and the audience.
I think we can move to backend because
Backend?
there are a lot of
Yeah.
questions related to backend as well in the audience. Yes.
Okay. All right. Okay. Wonderful. Okay. Just give me 1 minute. Okay. For the backend development path, like I mentioned, the two core important aspects would be to understand and master how data is stored in the backend in a database, and how the data needs to be secure. It has to be consistent. It has to be scalable. So that is the database part, right? So one needs to have a clear understanding the core concepts of any database, the whole structure of the database. It could be any database. It could be Cassandra, MySQL, MariaDB, MongoDB, Oracle, anything, right? So it's basically how you understand what is the structure of a database, how data is stored, how the database, how secure your data is, how the data should be up to date. It should be persistent. It should be consistent. So all these things you need to have a very clear understanding with the database. The other one is the processing language, right? How a data is processed, how you receive a data from the client, process it, and store it in a database. So we have API sockets. You have different methods like long polling, short polling, various methods, and of course the languages which are kind of popular is JavaScript, that is Node.js. Then you have Python, you have Golang, you have Ruby on Rails. You have a lot of these languages, right? So am I still sharing my screen? Just want to understand.
No, Mr. Ekambaram, we can see you.
No, but is my screen PowerPoint presentation still shared,
It's
right?
not visible.
Okay, 1 second. Let me share it. Sorry. So is everyone able to see it now?
Yes, Mr. Ekambaram, it is
Okay.
visible now.
Okay. So some of the languages that I've put for the backend development suite, the languages are JavaScript, Node.js, Python, Ruby, right? And of course the framework where we use, so which makes our the coding journey more structured, more easier, because it's very hard to write long cumbersome code. So all these frameworks makes it easy. You have JavaScript, you have Express, then Python, you have Django, Ruby on Rails, and Java Spring for Java, right? So these are the frameworks. And then the databases, just to mention a few: MySQL, PostgreSQL, and MongoDB. So for the backend development journey, the database learning, understanding it's very hard to say, okay, I've understood what a table is, what the database structure is, what are forms, which is a primary key, secondary, all these things are there. But then how will you really get to know whether you've completely understood It's only when you start implementing, right? Doing a project, or trying to clone something, to understand how it is stored, all these things. So if you need to spend some quality time on the database itself. So it takes somewhere around 2 to 3 months, depending on how much time you would be able to spend, right? See, again, it depends. It is like there's like 3 to 4 hours in a day. It's not like 8 or 10 hours in a day. But then, if you are consistent, if you're very if you're dedicated, if you have that passion, if you're able to spend, yes, definitely you can completely understand. This is a self-learning, right? Of course, the you have a structured curriculum where it's a little different. Maybe you'll take a lesser time, but then the good thing about self-learning is you start to think on your own. Okay, I have this. How do I implement this? What are the steps that I need to do to put the data correctly into this? So these kind of things, right? Self-learning is, you have that advantage and that freedom, right? Then the language that you need to learn, it depends, right? It could be Node.js, JavaScript, or Python, or Ruby, depending on your whatever language you like, where you want to pursue the thing. But the most common thing is Node.js, right? Popular one. And the integration part, this of course, it takes a longer time with your learning journey, with how you evolve, how you understand, writing HTTP, then understanding the internal fundamentals, then Linux, like understanding files, permissions, then the whole thing, how it is mapped to the server backend, the database, and then the cloud computing, because everything is moving into cloud. It is definitely very essential to understand the cloud technologies. And the three big players are Amazon, Google, and Microsoft Azure, right, for cloud. And the backend also has some miscellaneous things, like when you want to post a code, make it public, you have to put it in GitHub, right? You have to use GitHub. Then you need to test your code. There are a lot of testing tools like Selenium. You have Google Chrome. I think testing tools, that you have other testing tools. Then you need to do continuous CI and CD. This is another process where you need to follow a particular framework, so that you have things which are structured in order, and which is very consistent. Then I would touch upon the projects. See, doing a lot of projects is something good, but then even if you do just 2 or 3 projects, which is of medium complexity, like let's say you clone a website, right? Something like a Paytm, or anything for that matter, right? Like Twitter or Facebook, whatever. But when you put it as a project, when you go for an interview, I'm coming to that, but I just want to mention this. They will ask you, what additional feature have you done? See, you have done this because already there on the internet. Okay, you try to do a prototype or a model, but what you need to basically bring out, what additional features that you have added, right? I'll come to that. Then here I would want to play another video with respect to the backend technology. This is also very, very interesting. I would want everybody to watch this along with me, because this again gives you a very, very macroscopic broad view about what are the technologies, what are the essential backbone structures, the building blocks for backend development, right? Just give me a minute.
Every website can be split up into two parts.
Is it clearly visible and is it audible?
Yes, Mr. Ekambaram, it is visible and audible.
Okay, thank you. Okay, let's watch this. Thanks.
The front end and the back end. The front end is all the visual stuff you see on the web page, and the back end is what saves and manages your data. For example, if you are on Amazon.com, the back end would store your order history, your profile, it would load search results, and much more. In this video, we're going to take a look at the technologies that are used in the back end of a website, and in another video, we explore the front end technologies. As an example, let's say that we're on Amazon.com and we do some shopping, and now we're ready to make an order. When I click place order, what happens? We're going to start from the ground up. Any computer that's connected to the internet, including your computer and my computer, can send a message across the internet to another computer that's also connected to the internet. So to simplify things, Amazon has a computer in their office building somewhere, and our computer is going to send a message containing our order to that Amazon computer. In this scenario, the computer that is sending the message is called the client, and the computer that is receiving the message is called the server. But before this happens, computers, they can't receive messages from the internet by default. We have to program them to be able to receive messages. To do that, we need a backend programming language. Almost every programming language has a feature that turns a computer into a server and allows it to receive messages. Popular backend programming languages are JavaScript, sometimes called Node.js, Python, Ruby, and Java. However, using a backend programming language by itself is actually really difficult and requires a huge amount of code. So there are two tools that we use to help with this: a backend framework and a package manager. A backend framework helps us create a server much easier and with a lot less code. Each backend programming language has a few different frameworks to choose from, but the most popular ones are Express.js for JavaScript, Python Django, Ruby on Rails, and Java Spring. In the backend, we also use a lot of code that other people have written called packages to do common tasks like doing calculations, talking to a database, and setting up user login and authentication. We typically use a lot of packages in our backend, and in order to install and manage all these packages, we use something called a package manager. Each language has its own package manager. The most popular ones are NPM for JavaScript, pip for Python, bundler for Ruby, and Maven for Java. These are all the technologies we need to create our backend server. The next problem we have is we need somewhere to save the data for our website. Going back to our Amazon example, data could mean our user data, like the login information, order history, as well as data for all the products that are being sold on Amazon, the descriptions, the ratings, and the reviews. To do this, we use a database. A database helps us store and manage data. It's just a piece of software that usually runs on a different computer, and we have to do some setup so that our backend can communicate with the database. The most popular databases are MySQL, Postgres, and MongoDB. Alright, so if you're just starting out, this is basically all you need for the backend. You can build most of your projects with just a server and a database. For example, here's how our Amazon scenario could work. When the customer places an order in the front end sends a message containing the order to the backend. The backend then saves the order to a database and sends back a message to the front end confirming that the order was created. The message that the front end sends to the backend is known as a request, and the message that the backend sends back is known as a response. This is called a request-response cycle, and this is generally how web applications work. Here's another example. Let's say that you're in the Amazon warehouse. The warehouse might have a different front end that sends a request to the backend to get our order. The backend then gets our order from the database and sends it back to the warehouse front end, and then they go ahead and prepare our order. Now that we've seen the overall flow, we're going to dive deeper and take a look at what's inside a request. Here's a simplified example of a request to create an Amazon order. If we read over it, we can see that it's actually really easy to understand. We have the items that we ordered, the quantities, and some other information about our Amazon order. At the top, we have the type of the request, the domain name, and the URL path. This describes where this request is going and what type of request this is. First of all, Amazon, the company, has bought the domain name Amazon.com, and they configured it so that any requests going to Amazon.com will be redirected to that server in their office building. So that's why we're sending this request to Amazon.com. The type and the URL path identify what kind of request this is. So in this example, this is a post request to /orders. In the backend, we use our programming language and backend framework to define what types of requests are allowed and how we should handle these requests. For example, we can allow a post/orders request, and whenever we get a post/orders request, we will create an order using our programming language and save it to our database. We can also allow a get/order request, and in this case, we will retrieve the order history from the database and send it back as a response. Another example is a delete/order request where we will cancel the order. So this list of all the different types of requests that the backend allows is called an API, Application Programming Interface. The API is one of the most important concepts in backend programming. If you send a request that is not allowed by the API, the backend will respond with an error. So we mentioned earlier that we can identify requests using a type and a URL path. There are several types we can choose from, such as post, get, put, and delete, and the URL path can be anything we want. So why in this example did we choose post/orders? This is just a naming convention for our requests, and this naming convention is called REST, Representational State Transfer. In REST, the type of the request has a special meaning, so post means to create something, and in this case, post/orders means to create an order, get means to get something, and delete means to delete something, and so on. An API that uses the REST naming convention is called a REST API. REST is the most common convention that we use for our APIs, but there are several other conventions that we could use. One of them is called GraphQL, which uses post/GraphQL for all of our requests, and another one is called RPC, which uses post and a more detailed URL path like post/create order or post/get order history. So that is what a request is, what an API is, and what REST means. Now let's talk about infrastructure. Nowadays, instead of companies purchasing their own computers to run their websites, they rent computers from a cloud computing company. The biggest cloud computing companies are AWS, Amazon Web Services, GCP, Google Cloud Platform, and Microsoft Azure. The basic idea of cloud computing is you're renting a bunch of computers. This is also known as IaaS, Infrastructure as a Service. Behind the scenes, AWS has a giant, powerful computer, and inside its software, it's running many smaller computers, and we're actually renting one of these smaller computers. And these smaller computers only exist in the software, so we call them virtual machines, or VMs. So to run our website, we rent a VM from AWS to run our backend, and we also rent another VM to run our database. Another problem we have to solve is, what if our website gets really popular during the holiday season and we start getting a lot of requests and internet traffic that our server can't handle? With cloud computing, we can set up multiple VMs running the same backend code and then set up a special VM in front of these called a load balancer. And the load balancer will distribute requests evenly across our VMs. Once the holiday season is over, we can just shut off our VMs when we don't need them. This is a lot easier than having to buy physical computers, where if the holiday season is over, you still have the physical computers that you paid for. But we still have another problem. We now have a lot of VMs that we need to create and set up, and it takes a lot of time and effort. Cloud computing companies offer another service called a PaaS, a platform as a service. A PaaS just lets us upload our backend code. It will set up all the VMs, including the load balancer, and integrate everything for us. The three most popular PaaS are Elastic Beanstalk for AWS, App Engine for GCP, and App Service for Microsoft Azure. The next concept we're going to look at is microservices. For our Amazon example, let's say that our backend contains code that saves an order to the database, charges the user's credit card, and sends an email confirmation. In the real world, this backend can be millions of lines of code, so we split this up into 3 code bases. Then each of these code bases will have their own backend, each with a load balancer, and sometimes their own database. Then when we need to send an email, our orders backend will send a request to the email backend, which will send the email. So splitting up our backend into separate backends like this is called microservices, and it helps keep our code base smaller and more focused. Each microservice does not have to use the same programming language and database. One microservice can be using JavaScript and MongoDB, while another microservice can be using Python and MySQL. Now, to make this even easier, there are companies out there like Twilio who have already created an email service. So Twilio provides a backend and an API for sending emails. So instead of us creating our own email microservice, our backend can just send requests to Twilio's backend. When a company provides a backend and an API that outside applications can use, this is called a SaaS, software as a service. Pretty much everything you do in the backend that's complicated, there's probably a SaaS company out there that already provides that service, and you can just use that service instead of building your own microservice. So these three concepts we just looked at, infrastructure as a service, platforms as a service, and software as a service, are the three foundations of cloud computing. These days, most companies use cloud computing to run the backend for their websites instead of buying and managing physical servers themselves. In this last section, I want to introduce some additional technologies you might see in the backend. Previously, we mentioned the databases MySQL, Postgres, and MongoDB. These are sometimes called primary databases because they're the main database that our website uses. Generally, we start our backend with a server and a primary database, and then bring in these additional technologies if we need to. If we allow our users to upload images, a primary database is not good for storing images, so we would use a blob store like AWS S3 and a CDN like CloudFront to store and load user-uploaded images. If we want to allow text search, primary databases are very slow at text search, so we would bring in a search database like Elasticsearch. If our website is getting a lot of traffic and we need to take some stress off our primary database, we would add a cache like Redis to improve performance. If we want to do data science, we don't want to do the data analysis using our primary database. It's busy running our website. So we would copy all of our data into an analytical database like Snowflake, which is really good for doing data science on the side. If you want to schedule a task for later, for example, Amazon might want to email their users before their Amazon Prime subscription renews, we would use a job queue like RabbitMQ to schedule this task for the future. And there's a bunch more technologies like these out there that are made to solve specific problems. So these are all the backend technologies that we covered in this video. If you're just starting out, you mostly just need to know how to use cloud computing, a backend framework, and a primary database. These other technologies are things that you may or may not use. You would add them to your backend depending on what kind of website and features you're trying to make. Thanks for watching. My name is Simon from supersimple.dev. I want to make a tech career possible for anyone. If you have any questions or comments, please leave them down below, and I'll see you in the next one.
So how was the video? Participant, was it really good? Was it useful?
Lots of thumbs ups and lots of hearts for you.
Okay. Thank you. Thank you. All right. So I think we still have about 10 minutes or 15 minutes.
Well, we're almost done with the session.
Okay.
It was about 9:20. Yeah, we got a minute left.
Oh, okay. I'm sorry. I should have had a little more time for but I felt that this is very, very important to have a very clear understanding. I just wanted to mention, when you go for the interview, it's important for you to understand when how to nail the interview. Is that it's important that you put your code in GitHub and you've already tested it and you have it ready for implementation, right? That will give you the edge. The other thing is, what is important whenever you answer, like be it front end, back end, or the complete full stack, it is important the way you answer questions in an interview is that what value are you trying to bring in for the organization, and that will set you apart.
Tamisha, you want to take over?
Yes.
Yeah.
Thank you for your helpful insights, Mr. Ekambaram. It has
welcome.
indeed set the pace for the audience and got them thinking.
Yes, thank you. Thank you so much.
Our audience does have questions, but in the interest of time, it would be
Yes.
great if we can email them to you. And if
Yes,
you would be kind enough to answer as many of them as possible.
definitely. I'll do my best.
Thank you so much once again, Mr. Ekambaram. You can
Yeah.
exit the webinar now
Yeah.
while we continue on a marathon of sessions.
Okay, thanks once again to the EduBridge team for giving me this opportunity. And thanks to all of the participants for taking your time and interest in attending this session. Have a wonderful day. Thank you very much.